Okay, so we're going to do homework 13 calculus class today, and we're going to do part of the assignment. This is a long assignment. It's covering everything in the semester so far, and that's why it's weeks and half weeks to do or something like that. Anyway, let's start with question 1. We have integral of cosine of x dx. This is a u substitution. We're going to let u equal 3x. That's the side of the function. And then we're taking the derivative of this. We get the derivative of u equals times the derivative of x. That means that this integral up here, we can swap it for integral of cosine of u. And then I want to swap this to dx. dx 1/3 d 1/3 d here. The 1/3 can be factored out, and that means we get 1/3 times the integral of cosine of u, just sine u. That 1/3 sits outside. We have a constant. Check this by taking the derivative. Oh, I do have to convert back into x's. Not quite. 1/3 sine of u is 3x. This is our final answer. Let's check by taking. I have 1/3 of this chain rule. Take the derivative of the outside, which is sine of the cosine function, with the 3x plugged into it. And then we multiply it by the derivative of the inside function. The inside function is, and this c here goes away when we take derivative because the derivative of a constant is. This third and this 3 cancel, so we're left with cosine of 3x is the derivative of this, the derivative, which means that that is the antiderivative, like we claimed. Going. Next problem we have is a limit. Have the limit as x goes to 0 of x to the 6th plus 6x to the 3rd over 4x to the 5th plus 3x. And while we could use L'Hopital's rule, I think I would first factor the x's out and see that we can rewrite this as the limit as x goes to 0 of x cubed times 2x cubed plus 6 over x cubed times 4x squared plus 3, and the x cubes will cancel. This limit then equals the limit as x goes to 0 of 2x cubed plus 6 over 4x squared plus 3. If I just let the x's go to 0, we get 6 over 3, which is 2. That is our answer. On to the next question. And we're only going to go for about half an hour right now. We probably won't finish this, but I'll come back tomorrow and I'll record a few more problems, see how far we get. We have a function. F of x is squared minus 3x 9, x less than or equal to 2, and kx plus 1, or x is greater than. We want to know what value of k makes this continue. So since we are splitting between the functions at x equals 2, basically we want, when we plug 2 into this function, we want it to equal the same thing as when we plug 2 into this. That'll get us the property that we need. So we'll plug 2 into each of these and see what we get. We get 4 minus 6 plus 9 should equal 2k plus 1. That means that we have 7 minus 1 equals k. So k equals 3 should be the answer. Factor this here. I'm going to factor poorly. Yeah. We could check this by graphing. Like it. Honest. Okay. That's how you do that, is you set the two pieces of the piecewise function equal to each other, plug in the boundary point where we want them to equal each other, and then solve for the variable. That'll give us. Okay, so now we want to go on to the next problem, which have a function f of x cosine to the third of 4x, and we want to find f prime of x. This is a chain rule. So the outside function is the cube function. The outside function. The function inside of that, immediately inside of that, is the cosine function. The function inside of that is 4x. Derivatives of these are 3x squared, negative sine x, and 4. What we're going to do is we're going to take this function here, and we're going to plug this function into this one, into that one. We get 3 cosine of 4x squared. Then we're going to take this function and plug this one into it, times negative sine of 4x. And then we're multiplying. You can simplify. Get 12, negative 12 sine of 4x cosine squared of 4. Our derivative. So bad. Hey, question number 5. Question number 5. We have f of x equals 2x cubed minus x squared minus 12x. We want to find out where this relative minimum. So let's take a derivative to find out what the extreme points are. 6x squared minus 6x minus 12. Factor a 6 out of this. X squared minus x minus 2. That factors as 6 times, well, things that multiply to give 2, that subtract to give negative 1. We have x minus 2, x plus 1. We check this. X squared minus 2x plus x is negative x minus 2. Okay, so that means that our points, potential maximum and minimum, are x equals 2 and x equals negative 1. Those are potential minimums. We can check if they're minimums or maximums by looking at the second derivative. We get 12x minus 6. If we plug 2 into that, we get 24. Minus 6 is 18. That means minimum. It's positive. F double prime of negative 1 gives us negative 18. Negative, so this is a local maximum. We were only asked to find the minimum, so the local minimum, the only local minimum is that 2. And if we wanted to figure out what that minimum value was, we could plug it into the original function. Plug 2. Question 6 says we have a function f of x 2x minus 1 fifth times x plus 1. We want to find out which of the following is an equation for the line tangent to the graph at the point where x equals. So we're going to need to find a derivative. This is a fairly big function, so I don't want to multiply that out. We can use the power rule for this. We have the derivative of the first function times the second. Use the chain rule to find that. And then we do the first function times the derivative of the second. Derivative of the second chunk. And let's see. Then we need to figure out the slope by plugging this in. Well, to find the tangent line, we need the point that we go through. So we're going to plug 1 into this to get the y value of the point. We'll plug x equals 1 into the derivative to find the slope of f of 1 equals, like, 2 minus 1 is 1 to the 5th times 1 plus 1 is 2, so it's 2. That's the y coordinate, the point we're going through. The slope is going to be 5 times 2 minus 1 is 1 to the 4th times 2 times, well, 1 plus 1 is 2, plus 2 minus 1 is 1 to the 5th times 1. So we get, this part is just 1. This part is 20. We get 21 as the slope. And then let's use point slope form. We have y minus the y coordinate of the line equals slope times x minus x coordinate of that point. That's a line. If we want to put it into slope-intercept form, we can multiply it out and go over 2 plus 21x minus 21, y equals 21x minus 19. There we go. We have the antiderivative of e square root of x over square root of x, x. This is another u substitution. By the way, u substitution is just the integral version of the chain rule. So if you look at the two things side by side, you can see how they're just the same technique. Just one of them is you're finding the derivative, and the other one's you're finding your integral. Anyway, I'm going to let u equal square root of x. That means that du equals, this is going to be 1 over 2 root x dx. Prove that. Square root of x is x to the 1/2 power. The derivative of this is the derivative of that. This is a power rule, so we take the power down in front, and we subtract 1 from the power. Well, 1/2 minus 1 is negative 1. Negative powers turn into reciprocals. And again, 1/2 power is a square. So the derivative of the square root of x is 1 over 2 times the square root of x, which is what I said it was. So we're going to do a u substitution. We have the integral of e to the u over u d, well, dx is 2 x, but u is square root x, so that's dx 2 u du. So this becomes, dx here becomes 2 u get e to the u. The antiderivative of e to the u is u plus a constant. And then we substitute back u is square root of x, so this becomes 2 square root x plus a. That is our antiderivative. Check that by chain rule. 2 x plus a constant if derivative. By the way, checking all of your answers on the homework is a great way to practice more calculus skills. At this point, we can take integrals and we can take derivatives. The way that you check your answer is by doing the other. So practice taking an integral, check it by taking a derivative, and that way you're practicing skills in the same problem. Anyway, I take a derivative, ddx of this, chain rule. The outside function is 2e to the... It's 2e, something plugged into the exponent. That's a 2e to this root x. And we multiply by the derivative of the thing inside of the function. It would be 1 over 2x. The derivative of the constant goes away. Like, the derivative of the constant is 0, so that goes away. And we can cancel the 2's. This gives me back e to the root x over root x, which is our original function in the original integrand. Okay. We can make it to 10 before we run out of time for the... We did not do integral approximations. Question 8 shouldn't be on the homework. I'll scratch it now. Oh, that is not something we talked about yet. So we'll go to question 9. Particle moves along the x-axis so that any time t greater than 0, the velocity is given by of t 4 minus 6 squared. Particle is at position x equals 7 at time t equals 1. What is the position of the particle at time t? So what we want to know is, we want to know how far the particle traveled between time 1 and time 2. The velocity is 4 minus squared. If we take the integral of that, we'll know how far it traveled. Since we know where it started, we can add where it started to how far it went and figure out where it ended up. We get 4t minus 1/3 of 6 is 1/3. We evaluate that from 1 to 2. We get 8 minus, 1/3 is 8 times 15, minus 4 minus 2. Get negative 8 minus negative 10. So it's traveled 10 to the left. But it started at 7. So it started at 7. The distance it traveled is negative 10. Its stopping point is going to be 7 minus 10 equals negative 3. Okay. For 10. We have a function f of x, ax squared plus 12 over x squared plus b. Figure shows a graph of f, this, I can just copy that. There we go. It asks, what could A and B be? Well, we have a vertical asymptote here. We have this vertical asymptote at 2. We need 2 to be a factor of the denominator. So if 2 is a factor of the denominator, that means that we need to plug in 2 and get 0. 2 squared plus 0. So b equals negative 2 squared, which is 4. So if we get b is negative 4, that looks good. And then we want to figure out what, well, if we have a horizontal asymptote at 3, that means that the leading term, which is ax squared, of the numerator divided by the leading term of the denominator, which is x squared, has to equal 3. But the x squareds will cancel on that. Also, they have to be the same degree, but they are, so that's... we have degree 2 term and a degree 2 term here. Degrees, the x's will cancel out. Whatever the quotient of those two leading terms are, if the degrees are equal, is the horizontal asymptote. So that's 3. This equals 3, but the x's cancel. That means that a equals 3. So our answer is a is 3, b is negative 4. That got us through 10 of the questions, and that'll be what we get to today. So do another half hour or so tomorrow, maybe longer if we can. But those are the first few questions of